Hi there everyone. Recently Rotor did a video where Alex Vanover showed us all how you can run a KISS flight controller with a BLHeli ESC. But should you do that? Well, today we're hopefully going to be looking to answer that question. I've got the FETTEC 45 amp 4-in-1 ESC here on the test stand, and I'm going to be putting it up against a BLHeli32 and a BlueJay ESC to see which is best. And we're also going to be talking about one of the technologies that the FETTEC ESC really boasts about, which is full sinusoidal commutation. Let's not waste any more time. Let's get right into the testing. So let's compare the ESCs that we're going to test now. Representing FETTEC, we have the FETTEC 45 amp 4-in-1 ESC. For BLHeli32, we have the Diatone Mamba F55 Pro 128K ESC. And representing BlueJay, we have the Chaos BLHeli 30 amp ESC. The FETTEC ESC is going to be using 128 kHz PWM frequency, and the BLHeli32 and BlueJay ESCs are going to be using the PWM settings that I found to be best for those ESCs in my previous testing, which is 16 kHz to by RPM for BLHeli32 and 24 kHz for BlueJay. The FETTEC ESC has a 45 amp rating with active current limiting, and BLHeli32 ESC has a 55 amp rating, and the BlueJay ESC has a 30 amp rating. And when we're looking at price, the FETTEC ESC is by far the most expensive. The BLHeli32 ESC is more reasonably priced, but the BlueJay ESC is by far the cheapest. I'd like to give a brief shout out to Unmanned Tech in the UK. They've been really supportive of all my ESC and motor testing and sponsored the FETTEC ESC that I used in this test. Let's talk now about full sinusoidal commutation. Now, this is a technology that FETTEC used to differentiate themselves from BLHeli32 and BLHeli ESCs, so it's definitely worth us understanding how it works and what it does. While a motor is running, there are 3 phases, and these phases are becoming active at different times. Each phase is driven first in one direction and then in the reverse direction, and there's also a period of time where the phase isn't driven. And by driving the phases in a certain order and in a certain way, the motor can be accelerated and spun in the correct direction. Now, with full sinusoidal commutation, during this period here where phase A is active, the PWM duty cycle that the ESC is applying to the phase is modulated to produce this sinusoidal shape in the current that's flowing through the phase of the motor. In comparison, in trapezoidal drive, the PWM duty cycle is just kept constant for that whole period. So in a sense, trapezoidal drive is simpler. We just drive the same PWM duty cycle for the whole time, and sinusoidal drive is a little bit more complex. We actually modulate that PWM duty cycle to produce a sinusoidal shape while the motor is being actively driven. It should be noted that BLHeli32 also has sinusoidal drive. They call it sine modulation mode, and BLHeli32 only uses sinusoidal drive at low RPMs. Once the motor is spinning more quickly, the ESC transitions smoothly to trapezoidal drive, and we'll see why that might be the case when we look at the test results. Looking first at efficiency and thrust, in my testing, the BLHeli32 and BlueJay ESCs were about 8% more efficient on average than the FETTEC ESC. Sinusoidal mode was less efficient than trapezoidal mode on BLHeli32, but on FETTEC, both sinusoidal and trapezoidal modes were similarly efficient. At the top end, FETTEC's sinusoidal mode produced about 5% less thrust than trapezoidal mode, and overall about 5% less thrust than BLHeli32 and BlueJay as well. Trapezoidal mode provides more top-end power by its very nature, and my understanding is this is why BLHeli32 transitions from sinusoidal to trapezoidal mode when you have that sinusoidal modulation selected. It's to make sure that you still have that trapezoidal top end power while you have the sinusoidal mode active at lower RPMs. So why is it that we're not seeing much benefit from sinusoidal drive modes with a typical 5-inch motor? Well, it turns out that there are two types of brushless DC motors: sinusoidal motors and trapezoidal motors. And the difference is in the design of the motor, the design of the permanent magnets and the windings. Sinusoidal motors use permanent magnets with variable flux density, which gives them a back EMF waveform that looks more like a sine wave. Trapezoidal motors use permanent magnets with a uniform magnetic flux density, and that gives them a back EMF waveform that's more like a square wave. It turns out that for our drones, we are all using exclusively trapezoidal motors. And the reason is that trapezoidal motors provide more peak torque and more power density than sinusoidal motors. And obviously for something that flies, we care an awful lot about the amount of power that we can get from a motor of a certain weight. They're also simpler to commutate, which is another benefit. And the fact that they have worse low RPM and vibration performance are trade-offs that I guess we're happier to accept. I mean, we never run our motors at low RPMs on a drone because the props are always spinning quite fast. And noise and vibration, obviously we would like to minimize that as far as possible, but probably not at the expense of power. Sinusoidal motors do have some benefits in other applications where you're looking for a very smooth motor and one that's particularly smooth when it's rotating at low RPMs. But this is not the application that we have, so we're using trapezoidal motors. And I think when I understood this, I realized that, well, it makes sense then that we wouldn't see much benefit from using a sinusoidal drive on a motor that's designed to be driven in a trapezoidal mode. In a sense, the motor is expecting and designed to accept trapezoidal drive, and so that's going to be the drive mode that performs best. The next thing we're going to look at is motor responsiveness, and this is a really critical parameter for the handling of a quadcopter. It really determines how fast the ESC can speed up and slow down a motor in response to signals from the flight controller. And the faster a motor can accelerate and decelerate, the faster it can change its thrust, and therefore the more stable the quad is going to be in the air, because the flight controller is constantly needing to make small adjustments to the thrust from all four motors to keep the quad stable. The faster the motors respond, the more stable the quad is going to be. We can measure it using a T90 time, and this is the time taken to reach 90% of a target RPM change. So here we're stepping from 5.5% throttle, which is a typical idle throttle value, up to 50% throttle, and then back down to 5.5%. And we're measuring the time to reach 90% of the RPM change. And by going to 90%, we help avoid all of this noise up here that might skew the results. We measure the acceleration time, and then we measure the braking time, stepping the throttle up first and then stepping it back down. FETTEC really seems to struggle with acceleration compared to BLHeli32 and BlueJay. However, it does appear to perform very slightly better under braking. We can see here that the FETTEC ESC is taking about 70 milliseconds or about 60 milliseconds, depending on whether it's in sinusoidal or trapezoidal mode, to accelerate the motor to 90% of the RPM change from 5.5% to 50% throttle. In comparison, the BlueJay and BLHeli32 ESCs, all the modes here perform very similarly. We can see that they are able to accelerate the motor about twice as fast as the FETTEC ESC, although they do perform slightly worse on braking, about 5 or 10% worse, let's say. I couldn't determine much of a difference between the trapezoidal and sinusoidal modes for BLHeli32, and there's also not much difference at all between BLHeli32 and BlueJay in this test. These values are slightly different to the values that I reported for these ESCs last time, because I've decided to use median rather than mean values for the acceleration and braking tests to better exclude outliers from the experiments. I was finding that the precise value that I got was very dependent on just one or two tests. And because I'm doing 20 or 30 repeats, the median is perhaps a better value to use rather than the mean here. Looking at smoothness now, and this I think is a really important parameter for freestyle pilots, and a lot of motor and ESC manufacturers talk a lot about smoothness. And I wanted to try and quantify it in a test. Now, my test stand has an accelerometer mounted to it, so it can measure the vibration of the motor as it accelerates and decelerates and as it ramps the throttle up and down during the testing. The accelerometer data is very noisy, so it is hard to distinguish small differences in the magnitude of vibration between different ESCs, but I've tried to do the best I can to clean up the data and average it appropriately. It appears that all the ESCs are very comparable in terms of this smoothness, this amount of vibration that they produce during the test. All the ESCs are using the same motor and prop, so that any differences is going to be down to the ESC and not the motor or prop. Overall, I think all the ESCs are very comparable, and I would say there's really not much to split them. If you had to give a small edge, maybe you would give it to FETTEC in the sinusoidal mode and BLHeli32 in its trapezoidal mode. But honestly, with the level of noise in the data, I think what I'm comfortable saying is that all of the ESCs performed pretty similarly. I have to talk now about an issue that I had doing this testing with the FETTEC ESC. Testing the FETTEC ESC threw up some issues that I hadn't seen before and are not present with BLHeli32 and BlueJay ESCs. What I found was that the initial data when I was testing the FETTEC ESC from the load cells in my test stand was very noisy and pretty much unusable. You can see here the thrust value and the torque value, and you can see these sudden spikes up and down. These aren't real. This is noise, electromagnetic interference, that's affecting the reading from the load cells. And I reached out to FETTEC and Taito Robotics about this and had really positive conversations with both companies. Felix at FETTEC performed some testing of his own and confirmed that the ESC was not behaving strangely and was certainly not responsible for these sudden spikes in thrust or torque. And Taito Robotics were very helpful in that they helped narrow down the cause to some sort of EMI issue on the load cells. Resolving the issue turned out to be quite easy. I ended up twisting the cables to the load cells and shielding the FETTEC ESC with copper tape to prevent any EMI affecting the PCB of the test stand that sits underneath it. That said, this testing, in my experience, definitely suggests that the FETTEC ESC produces more or different electromagnetic interference to the BLHeli32 and BlueJay ESCs I've tested. And I've now tested several BLHeli32 ESCs and not had this issue on any of them. So I would strongly advise considering an EMI shield when using the FETTEC ESC, particularly if your stack is quite compact. And something like this Mamba interference isolation board, which you can get from Diatone, is probably the thing that I would use. I should be clear here that I can't know that this issue will affect flight controllers or any other electronic components. I can only talk about my experience with my test stand. But I think better to be safe than sorry, and I would advise you to use an EMI shielding board with the FETTEC ESC, and honestly with any ESC, to ensure that you don't have any electromagnetic interference from the ESC affecting the flight controller. So that brings us to the end of the testing, and there are a couple of conclusions that I think we can draw from it. The first is that sinusoidal commutation doesn't appear to offer any significant benefits for typical 5-inch motors in efficiency, power, responsiveness, or smoothness. And in fact, particularly in the case of the FETTEC ESC, there are a couple of areas where sinusoidal mode performed significantly worse than trapezoidal mode. So I would say if you're running the FETTEC ESC on a 5-inch quad, you're probably better off using trapezoidal mode. The second conclusion is that while the FETTEC ESC was competitive with BLHeli32 in terms of smoothness and power, it did fall behind a bit on efficiency, and it fell significantly behind on motor responsiveness, which is a key parameter for me for the flight performance of the quad and how stable it holds itself in the air. If you're in the market for a new 4-in-1 ESC and you're considering the FETTEC ESC compared to a comparable BLHeli32 ESC, then I think the price differential definitely would push me in the direction of the BLHeli32 ESC, and it does perform slightly better in certain areas as well. One thing that should be noted is that if you're using a BLHeli32 ESC with a KISS flight controller, you are going to need to repin the plug that connects the flight controller to the ESC, and that can be a bit of a faff. Obviously, you won't need to do that with the FETTEC ESC. If you're in the market for an ultralight 5-inch frame, I want to let you know that the AOS UL5 is now available on CNC drones. This is the frame here, and it's the first AOS frame that's going to be offered in coloured carbon fibre. You're going to have a choice of colours: blue, gold, green, red or silver. Now we do expect the colours to go out of stock really fast initially, so if you have your heart set on a particular colour, it's probably best to order that sooner rather than later. Unlike other coloured carbon frames, like the 250 for example, we are going to be offering spares for the UL5 in coloured carbon fibre going forward. So don't worry about buying a coloured frame and then not being able to get that particular colour for spare arms and camera plates. Spares are going to be available going forward, and I'm really excited to be able to bring coloured carbon fibre to the AOS lineup. Although this is the first AOS frame to be offered in coloured carbon fibre, I can promise you it's not going to be the last. I also want to give a quick public service announcement. Please make sure if you're running the FETTEC ESC to update your FETTEC ESC firmware, particularly if you are using sinusoidal mode, which is the default, as a number of bugs that affected certain motors were fixed relatively recently in newer versions of firmware. Should you have any problems with the FETTEC ESC and any motor, FETTEC and I suggest switching to trapezoidal mode, and based on the performance testing that I've done, I think trapezoidal mode is probably the best mode for 5-inch motors, regardless of whether you have any problems. So it might be worth just switching over, getting that extra performance benefit, particularly in terms of responsiveness, and then not having to worry about any potential bugs with sinusoidal mode. I hope you enjoyed the video and you felt like I did a fair, unbiased test of FETTEC versus BLHeli and BlueJay. If you think I did a good job, please hit that like button so that other people have an opportunity to see this video as well. And if you think there's something that I could improve, please leave a comment down below and I'll do my best to respond to all the comments, as I always do. If you have an issue with your quad, whether it's a BLHeli32, BLHeli or FETTEC ESC, whether you're running Betaflight or KISS, head on over to my Discord server because we have a great group of people in the support hangar there who can help you troubleshoot any issues you might be having, whether it's on the ground or with the tune of the quad in the air. If you're someone with a lot of experience, I'm always on the lookout for people to help support other pilots as part of the ground crew or air crew on my Discord server. If you'd like to do that, please join the server and then drop me a DM and we'll get that sorted out and get you added to the appropriate crew. I also want to let you know that we have a community review recently posted in the product reviews channel of the Discord server by Yelmer, who's been looking at the Beta FPV Express LRS 1 watt transmitter. So if you're interested to read what he thinks about that, you can find that in the Discord server as well. If you like the work that I do and would like to support the channel, the best way you can do that is through Patreon. I'll put a link down in the video description and you can join from just a few dollars a month and you'll get access to special areas on my Discord server as well as sneak peeks of the projects I'm working on. You also get a special status, and for the higher tiers you can even get technical support with tuning your quad or your build from me directly. If today's the day you feel like I've earned your support, then please consider checking that out. If today's not that day, then I hope in the future I can work a little harder and earn that support from you. That's all I have for you for now. So until next time, I wish you all very, very happy flying.